In this video, we are going to continue with some examples of solving equations. When I look at the example on the screen, I notice there are no parentheses, but there are some like terms on the left-hand side of the equation. So what I'm going to do to start is to combine my like terms. So I have 3x, and make sure to include the sign in front, and negative 2x. So combining them together, I take 3 minus 2 on my calculator and I get x. Then I have the constant terms 7 and 8. Again, combining them, I have 15. Now you'll notice that the math I did here was not the opposite because I did not move them across the equal sign, but rather I just literally did the math to make it simpler. The rules that we have in our pre-lecture notes encourage us to get the variable terms together as our next step. So I personally am not a huge fan of the negative, so what I'm going to do is the opposite here of negative x is plus x. So I'm going to add x to both sides. On the left, x plus x is 2x plus 15 equals, and on the right, negative x plus x cancels, so 15. Our next step is to get the constant terms together and separate from our variable terms. So I'm going to subtract 15 from both sides to move that away from the 2x. So these cancel and I have 2x. Now this problem is in our video because something happens here that makes most of us a little bit uncomfortable. I have 15 minus 15, which truly does cancel. And as we saw on the left, when things cancel, I didn't write anything because it was a 0. However, if I don't write anything here, I have 2x equals and I have blank space. So I actually need to write my 0 because I need to have something on the right-hand side of the equation. So even though 15 minus 15 does indeed cancel, I need to write the 0 this time so that there is something on the right. Then I can continue. My last step in equation solving is to get the coefficient to be 1, so I divide by 2 on both sides. So the 2's cancel and I have x. On the right-hand side, I have 0 divided by 2. This can be done on your calculator, and the answer to that is indeed 0. When 0 is in the denominator, as we saw in week 1 of the course, that's when we have the undefined. But here with 0 on the numerator, the math can be done by your calculator, and the answer is 0. Let's look at a couple more examples and again refresh some of those details that come up in equation solving. So in this problem, I do see parentheses, and I know that I have to do them first. When I distribute, make sure you're distributing the sign along with the numbers. So I'll distribute that to the x and to the negative 6. So the 5.8 is not being distributed. That's just continuing. Negative 0.3 times x will be negative 0.3x. And then negative 0.3 times negative 6. Two negatives make a positive, so that will be positive. And you're welcome to use your calculator to do that math, 1.8. Now, the next step, which is written in our notes as part of this first step, is the combining of like terms. And so you'll see here, I have the constant term 5.8 and the constant term 1.8 on the same side. And so I personally added those two together, and that gave me 7.6. I still have my minus 0.3x, and that's equal to 0.5x. Now I can get this negative 0.3x over with the other variable term, so I'll add 0.3x to both sides. So I have 7.6 is equal to 0.8x. And finally, I'll divide by 0.8 to get my answer so that my coefficient on the variable is 1. And again, I'm using my calculator here, so I'm typing in 7.6 divided by 0.8, and I get 9.5 as the answer. And my pen's challenging there, so let me rewrite. 9.5 is equal to x. So on this problem, really the only thing that is new compared to some other examples is that we have the decimals, and so I'm relying on my calculator rather than mental math to be doing the arithmetic, the adding, subtracting, and the dividing as I work through that equation. Our next example brings in a problem that has fractions, and fractions are always more challenging when they're mixed with an algebra equation. When I look at the fractions, the denominator is one of the things that we're going to need to deal with, and so I'm just taking note. I have a denominator of 4, of 2, and of 3. Many of the strategies for working with fractions within an equation is to get a common denominator. And so in order to get a common denominator, you have to get a number that all of the denominators would multiply into. And so when I look here, 4 times 2, well, that would be 8, but 3 doesn't have a whole number that multiplies it up to 8. If I look at the 4 and the 3, they would multiply together to get 12, and I also could get the 2 to become a 12. So my common denominator here, something that everything can multiply to become, is 12. Now, strategies vary for how to deal with the common denominator. I'm going to show you one strategy here in your notes, but if you prefer a different strategy, I am totally fine with that. So you don't have to do it exactly the way that I'm doing it. The way that I like to work with the common denominator is to multiply both sides by the common denominator. In keeping with our dimensional analysis, I'm going to put that as 12 over 1 and also put my whole number 3 as 3 over 1 so that I see both the top and the bottom. I know that whatever I do on the left, I have to do on the right, so you see me writing my 12 over 1 on both sides. Then I'll put my arrows here to show that I'm going to distribute on both the left and the right. And so we know from working with dimensional analysis that when we multiply fractions, we multiply the tops and we divide by the bottoms. So I'm going to show all my work, but you may do it all in one step. That's fine. 12 times 2 is 24x, and that is divided by 4. 24 divided by 4 is 6x. Then moving to the next one, 3 times 12 is 36 over 1, which is simplified to just 36. Have my equals. 12 times 5 is 60, so this is 60x over 2. Doing the math on that, that would be 30x. And finally, 12 times 4 is 48. There is a negative there, and that's over 3. 48 over 3 is 16, so minus 16. I like this strategy because once I finish the multiplication with the common denominator, I have all whole numbers, which I'm better at working with. But it is not the only strategy out there, so if you have another strategy that you like, you may go for it. From here, I need to get like terms together, so I'm going to minus 6x from both sides. Cancel, and I have 36 equals 24x minus 16. Add 16 to both sides. Plus. So this is 52 is equal to 24x. And finally divide by 24 on both sides. And I get x equals, and this is where I can have a challenge depending on the problem. So on my calculator, 52 divided by 24, I get 2.16 and the 6 repeats. So it will depend on how MyLab asks for the answer. So if they ask for a fraction in simplest form, you have some buttons on your calculator that can help you out with that. So right now, my calculator has on the 2.166666, and at the end of it, it has a 7. And then on my calculator, there is a button, and the buttons I use to get there is I use the second, and then diagonally down from the second, there's a button that says PRB. And in the fine print above that button, it has F, and then it has a double arrow and D. And this is what we're wanting to get at, fraction into a decimal and vice versa with the double arrow. So when I have this on my calculator from doing my division, I'm going to hit second, and then I'm going to hit that PRB button, and then I'm going to hit my equals, and my calculator shows me this, 2 union 1/6. And so it is the calculator's way of conveying to me that the answer here is 2 and 1/6. So if my lab is asking you for a fraction, use your calculator to get there. If it is asking for a rounded off number, you can use this. How did I get this? I got this by taking 52 divided by 24. And then I can't clear. I have to just continue if I want to get to the fraction. Because if I retype this, then I don't have it exactly in my calculator, and my calculator is not going to give me the fraction for that. So we're going to end our video here, and then we'll have another video with yet a few more examples of solving.